All right, we are moving on to 8-6. So 8-6, it says the objective here is to factor trinomials in the form of ax squared plus bx plus c. Okay, today we're going to be talking about where a is greater than 1. So for example, right here, a is 3. In 8-3, 8-4, 8-5, a has been something other, well, it hasn't been something other than 1. It's been just 1 the whole time. Okay, so how would you do this? Well, you got this solar panel here. Read the getting ready problem, pause the video, and try this one on your own. All right, assuming you've given it a go here, let's use the box method to figure this one out. Okay, so I know that the area of this is going to be 3x squared, and there's going to be a 36 here, and it says the height is x plus 3. So it tells me the height is x plus 3 right here. So I can write x plus 3 right here, and then I can kind of fill in the rest. It says, what's the length of this? Well, the length has to be the other dimension, so this has got to be 3x, because the only thing that x can multiply by to get to 3x squared is 3x. So x times 3x is 3x squared. And then I look here, and I have a 36 here, so the only thing that is going to multiply by 3 is going to be 12. Okay, so this is going to be 3x plus 12. And if I fill in the rest, the area will kind of work itself out. So 3x times 3 is going to be 9x, and 12 times x is going to be 12x. And when I add these two together, my like terms usually at diagonals, 12 and 9 is going to be 21. Okay, so that's just an introduction to factoring where a is greater than 1. All right, so just as a review here, standard form for a quadratic equation. We can squeeze that in here. We're talking about a quadratic equation. It is going to be ax squared plus bx plus c. Later on we'll say equal to 0. For now we're just going to do ax squared plus bx plus c. Okay, so whatever is by the x squared is your a value. Whatever is by the x is your b value. Whatever has no x and no variable is c, your constant. Okay, so how do you factor these? Well, you have to do something a little bit different. We learned how to do the x method, okay, where we just had an x. But when a is greater than 1, in this case it's 5, we have to add a little something here. Okay, and I'll explain this. So when we look at this value, let's label all of these. Okay, so I know that a is going to be 5. Okay, so I'll start off by labeling a, b, and c. I know that my b value is going to be 11. And I know that my c value is going to be 2. Okay, so when you're factoring these types of trinomials where a is greater than 1, you have to do a little bit different. So I'm just going to kind of write the template here. You're going to multiply a times c here. B still goes here. And then you're going to write ax here and ax here. Okay, so whatever a is there. So let's kind of figure this one out. So a times c is going to be 5 times 2. So this would be 5 times 2. This is going to be 10. Okay, and then my b value is 11. I'm going to write 5x right here. I'm going to write 5x right here. So I have 11 right here. And then I have to think about what multiplies to 10 and adds to 11. So what multiplies to 10 and adds to 11? Well, it's got to be 1 and 10. Okay, so I've kind of use the x method. Now what do I do? Well, one of my factors here is going to be 5x plus 1. Okay, so it's going to be 5x plus 1. And my other factor, once I get here, I have to kind of treat this like a fraction. I have to reduce this. So 5 and 10 can reduce to 1 and 2. So this is going to be x plus 2. All right, so I know that this, I can copy and paste this here, is going to be equal to my original trinomial. Okay, so this can be considered the area here in standard form, and this could be my length and my width. All right, let's relate that to the box that we did. We can kind of check it with the box. So I'm going to write 5x plus 1 here. Oops. 5x plus 1. Okay, we can call that the length, 5x plus 1. And the width is going to be x plus 2. So this is 5x squared. This is going to be 1x. This is going to be 10x. And this is going to be 2. Okay, so my width was x plus 2, and my area is going to be my original expression there, 5x squared plus 11x plus 2. Okay, so how do I get that 11x? This is a 10 right here. So my b value, let's kind of color coordinate all this. My b value was 11. So 10 and 1 makes 11. So that's where I get my 11 from. My constant was my c value, which is 2. Okay, so how do I get that? Well, 1 times 2. And then my a value, we used orange there. That's going to be 5x squared. Okay, we got that by multiplying 5x times x. All right, hopefully that helps you. You might have to pause that and look at that a couple times. All right, let's move on to the next one. Okay, pause the video, try this one on your own. Okay, see if you can factor this. All right, so factoring means you're trying to find two binomials that when you multiply them together, it equals the given trinomial. Or you can think of this as the area, and you're trying to find the length and the width, the dimensions. All right, so assuming that you've paused it, let's take a look. So I'm going to list all of my values here. I know my a value is going to be 6 right here. My b value is going to be 13. The b kind of looks like a 13. And my c value is going to be 5. So my c value is going to be 5. Okay, so I'm going to use that, and I'm going to do a times c. A times c is going to be 6 times 5, that's 30. My b value is 13. I'm going to write 6x right here and 6x right here. Okay, if you look back at the previous example, it's ax and ax. And then I'm going to factor this just like I did the x method. What multiplies to 30 and adds to 13? It's going to be 3 times 10 is 30, and 3 plus 10 is 13. Okay, and then I've got some reducing to do here. So 6x and 3, I can reduce that to 2x and 1. And 6x and 10, I can reduce that to 3x over 5. Okay, so treat this like a fraction. 6 over 10 is 3 over 5. 6 over 3 is 2 over 1. So now I have my factors. My length is going to be 2x plus 1. And my width is going to be 3x plus 5. Okay, and my area is what I was given, 6x squared plus 13x plus 5. And then the box method, you can use that to check your work. You can actually use it to figure it out. But I know that this is going to be 6x squared. And I know that this is going to be a 5 right here. So you can kind of guess and check and work it, 6 times 1, 3 times 2, something like that. But if you use the x method, you can kind of check it twice. So I know this is going to be 2x plus 1. And this is 3x plus 5. Okay, and if I do the math there, 2x and 3x is going to be 6x squared. So I get there, get that, and this is going to be 3x here. And 5 times 2x is 10x, and I get 5. Okay, so again, my a value was 6x squared. And I get that by multiplying 2x times 3x. My c value was my constant, 5. I can think of that as 5 times 1. Then my middle term, my b value, 10 and 3 makes 13. And that's going to be the right combination there to factor this trinomial. All right, last one for our notes today. Let's see what we got here. Yeah, let's try problem 2. Okay. So it says, what is the factored form of 3x squared plus 4x minus 15? So again, my a value is 3, my b value is 4, and my c value is negative 15. So when I do a times c, that's going to be negative 45. My b value is going to be 4. I need to make a little line here because my a value is greater than 1. So I got to, use this. Some people call it the magic x method. So it's no longer the x method. I got to add something else there. And then I'm going to write 3x here, just ax, 3x here. And the next thing I'm going to do is think about what multiplies to negative 45 and adds to 4. Well, sometimes it might be helpful to make a list. So all the factors of 45. I got 1 times 45. I got 5 times 9. Okay, I could do 3 times 15. That would somehow get me there. But the goal is to get to a positive 4. So how can I get to a positive 4? Well, if I make this a negative and make this a positive, that's going to give me the winning combination there. Negative 5 and 9 is going to be 4. So this is going to factor into a negative 5 right here and a positive 9 right there. And then I have to look and see if I can reduce anything. So this is 3x minus 5. Can't reduce that. So I know that that is a factor. And the other one, I can reduce this. So I can reduce this to 1x over 3. So my other factor is x plus 3. Okay, so, and then let's just check it with the box method, verify this. So this is going to be 3x squared. Check that off. This is going to be negative 15. Check that off. This is going to be 9x and negative 5x, which adds up to 4x. So we can check that off there. So I know the factors of this. If I write it small here, this is going to equal, go back and erase all this. This is going to equal 3x minus 5 times x plus 3. Okay, and notice I have an equal sign there. They're equal, because when I multiply them, these two together, I end up getting this. So length, width, area. That's how you should think of it. All right, so you may have to go back and watch that a couple times. Hopefully you guys are doing all right with this. Email me with any questions, and then I'll post the homework here for 8-6. We're going to break this down into 2 days. So day 1 is this video.